So we want to prove now, we want to prove that the cut, of y minus the cut of x, this is module 2 now, question 3, the cut of y minus the cut of x over the sine of y, well that's not sine, that's cut x, over the cut of x over the cut of x minus the cut of y. That's what we want to do. Okay, and we want to prove it. So this is the left hand side, of course, LHS. This is our left hand side. Always start with what your left hand side is. You want to do this proof. When you start with your left hand side, you expand out this right here. So let's expand it out. When you're expanding this, cut y, remember cut is cos over sine. So this is cos y over sine y minus cut x is cos x over sine x. And all of this is being divided by cut x is really cos x over sine x. Cos x over sine x minus cos y over sine y minus cos y over sine y. Now that we do that now, this is going to be equal to, simplify what is this now. To simplify this numerator, we multiply up the sine and multiply up sine y, multiply up sine x, multiply up sine y to write all of this as, this is now sine x cos y, sine x cos y minus cos x sine y, and all of this is being divided by sine y sine x. Sine y sine x. Now since this is what we're dividing by, all of this again will be divided by, join this as one fraction again, joining it as one fraction, it's going to be sine y cos x minus cos sine y cos x minus cos, cross multiply sine y cos x minus cos y sine x minus cos y sine x, and this is being divided by sine y sine x. All right, nice and easy. So what do I do now? This is then going to be equal to, now whenever I have a fraction divided by another fraction, I like to rewrite it another way that it is easier to understand. I'm going to rewrite it as sine x cos y minus cos x sine y minus cos x sine y, and all of this is divided by sine y sine x. Nice and easy. And it is divided by, since you're dividing by this, it's the same as multiplying by the reciprocal of this. And the reciprocal is going to be sine y sine x over all of this, which is sine y cos x minus cos y sine x. Nice and easy, soft. So what happens? So this sine y sine x cancel each other. And so we're left back now with this. We're left back with just in the numerator. We're left back with sine x cos y minus cos x sine y. And all of this is being divided by your sine y cos x sine y cos x minus cos y sine x. This works out to be equal to, when you have sine, then cos minus cos sine, that is just the sine of, it's just the sine of x minus y. It's just the sine of x minus y. And this one is just going to be the sine of y minus x. I'm positive that's what we have there. This one is just the sine of y minus x. All right, now let's see what happened. It says that should be, okay, I see what happened. Throughout this whole time, it was a plus. I had a minus here. There should be a plus. There should be a plus in the denominator, a plus in the denominator. So when I flip it, this is a plus, this is a plus. Okay, no issue. So now we prove it. Should be an x plus y. So now we prove it easy, soft, which is equivalent to our right-hand side. So that was an easy question. Let's go to the next part. The next part says, hence or otherwise, find the possible values of y in the trig equation when that is equal to 1. So straight away, we know it that if you're going to be solving the cotangent, if you're solving that the cot of y minus the cot of x over cot y minus cot x over cot x over cot x plus cot y. If you're solving this now, if you're solving this and you're solving it equal to 1, then pretty much what you're solving is that this implies that what we're solving is sine of the sine of x minus y over sine of x minus y over the sine of x plus y is equal to 1. All right, so that implies we can cross multiply the sine of x plus y to get that the sine of x minus y is equal to the sine of x plus y. This is what we're solving in reality. Sine x minus y is equal to sine x plus y. So you can expand out what all of these are. Sine x minus y is just going to be sine x cos y minus cos x sine y, and that's equal to sine x plus y sine x cos y plus cos x sine y. That's what we're solving. So if this is what we're solving, what can we do? What can we do? Let's think about it. Now, as we can see, we're solving this. All right, I have a sine x cos y here. Let's see what I can do. So if we bring over this, we're going to have sine x cos y. So sine x cos y cancels on both sides. Luckily for us, it cancels. If we subtract sine x cos y from both sides, we're going to actually see that we're just getting minus cos x sine y is equal to the cos of x sine y. And we don't even need to do that because they said that we should use sine x as a half. So we don't even need to do that. We can replace sine x with a half. Sine x is a half. So this is really a half cos y minus cos x. And now look what I'm going to do. Before I even go any further, I'm going to draw a triangle. All right. It's always easy with a triangle. If I draw a triangle with the angle x, the sine of x is opposite 1 over the hypotenuse 2. And so what that is telling me, if sine x is 1 over 2, then that is telling me that the adjacent is 2 squared, which is 4, minus 1 square rooted. So the adjacent is working out to be the square root of 3. All right. And so if that is the case, then what that is telling me then is that cos x, this is then telling me that cos x is equal to root 3 over 2. That's cos x. Cos x is root 3 over 2. So now we can do some substituting. Cos sine x is a half. Sine x is a half times the cosine of y minus cos x, and cos x is root 3 over 2. So read through root 3 over 2 sine y. And that's equal to sine x. Sine x is a half. We have a half cos y plus cos x again, which is root 3 over 2 sine y. First thing I want to do is multiply this equation through by 2. I don't like to be seeing so many half. If I multiply through by 2, and I'm going to get that cos y minus root 3 sine y. Let me put what I did right here. I multiplied through by 2. By multiplying through by 2, we get rid of that half in the denominator. And so what we end up with is cos y minus root 3 sine y is equal to cos y plus root 3 sine y. Now the cos y's are going to cancel clearly, right? If I bring cos y over here, cos y minus cos y becomes 0. And if I bring over here the root 3 sine y over here, root 3 sine y, bring it over here, I'm going to get 2 root 3 sine y, 2 root 3 sine y is equal to 0. That's what I'm getting. 2 root 3 sine y is equal to 0. Now that I get that 2 root 3 sine y is equal to 0, I can divide by 2 root 3. And so then that means that sine y must be equal to 0. And if sine y is equal to 0, then that is telling me that y is equal to 0 or y is equal to pi. Those are the two answers. But the question told me that, remember they said that x is between 0 and pi by 2. So from this, yep, these are the two possible values. All right, 0, 2 pi. Let's see if there's any more possibility. If we go around the circle one more time, we can also get 2 pi. So these are the three solutions. All right. So we can conclude, therefore, y is equal to 0, or y is equal to pi, or y is equal to 2 pi. All right. Nice. And you can actually test your answer and test it. We know that x is sine inverse of a half, which is pi by 6. So x is pi by 6. Try a value like y is 0. So if you have the sine of pi by 6 minus 0, this side would give you the sine of pi by 6, which is the sine of 30. Sine of pi by 6. This part is a half, and try this. This is good. Try when x is pi, when y is pi rather. Pi by 6 minus pi is going to be minus 2.61. Take the sine of that value. You get minus a half. Check it if you get the same over here. So pi plus pi by 6 and I'm getting the same. So these are the possible values of y. Y can be 0, pi, and 2 pi. Nice and easy, soft. Let's go to the next part of the question. Next part of the question says, f of theta is 3 sine 2 theta plus 4 cos theta. And it wants us to express it in the R-sine form. Let's go ahead and do that. It says f of theta is equal to 3 sine 2 theta plus 3 sine 2 theta plus 4 cos 2 theta. Nice and easy. That's f of theta. F of theta is 3 sine 2 theta plus 4 cos 2 theta. So if this is f of theta, right, and we want to express it in the r sine r cos form, the first thing is r is going to be equal to 3 square plus 4 square square rooted. That's r. And so that works out to be 5. And then theta is going to be equal to tan inverse of b over a. So theta is tan inverse. Theta is tan inverse of 4 over 3. So you put that in a calculator, what's tan inverse of 4 over 3? That gives you this value here. Tan inverse 4 divided by 3, that's 0.927. So what does that mean? That means then that f of theta is equal to r, which is 5, times the sine of 2 theta plus alpha, and alpha is 0.927 plus 0.927. Nice and easy, soft. Okay, let's go to the next part of the question now. It says, hence or otherwise, determine the value of theta between 0 and 2 pi at which f of theta is minimum. So they want when f of theta is minimum. All right, so let's find minimum value. Value of theta for which f of theta is minimum. Now, first thing I want to tell you is that f of theta is always bounded between r and minus r. This is part 1 answer. This is part 1, right? That's in that form. And this is part 2. This is part 2a. So first thing, f of theta is always between 5 and minus 5. That's the first thing we need to know. It's always bounded between 5 and minus 5. Now, f of theta is equal to 5. F of theta is equal to minus 5. It's equal to minus 5 when is sine going to be negative? We know that the sine of an angle is negative. If I were to call all of this x, it is negative when the sine of 2 theta, all right, let me write it better. F of theta is equal to minus 5 when the sine of 2 theta plus 0.927 is equal to negative 1. All right, that's when it's equal to minus 5. And so we need to solve for theta in this case. So first thing we're going to do is take sine inverse to get that 2 theta plus 0.927 is equal to sine inverse of negative 1. All right. So sine inverse of minus 1, you're going to get minus pi by 2. So you're going to get sine inverse of minus 1 is minus pi by 2. Of course, generally you get 2 answers, right? You want when theta is negative, all right? Generally they tell you to draw a circle, and they tell you that sine is negative. Sine is negative in the 3rd and the 4th quadrant. And then you find the principal acute angle in the 1st quadrant, which is pi by 2. And so then it's going to be pi plus pi by 2. And so some people actually write pi plus pi by 2. Some people actually write pi plus, oh gosh. Let me see if I can get that back. Yeah. So in the 3rd quadrant, as we said, the angle is what? In the first, it's pi by 2. The second, it's pi minus pi by 2. In the third, it's going to be pi plus pi by 2 when it is negative. And pi plus pi by 2 is 3 pi by 2. All right, so this is 3 pi by 2. That's one possible answer. Or, yes, or. You're wondering where the or come from. Or it can be 2 pi minus pi by 2. 2 pi minus pi by 2. And 2 pi minus pi by 2 is 7 pi by 2. So let's solve for theta in this case now. Let's start with the first one. With the first one, we're going to have 2 theta is equal to 3 pi by 2 minus 0.927. 3 pi by 2 minus 0.927 is 3.78. So this one is working out to be 3.78. Then you divide through by 2 and you get theta is equal to, and you divide that by 2, you get 1.89. That's one possibility, 1.89. And this is in radians, or the next answer would be 2 theta is equal to, you work out what is 7 pi by 2, 7 pi divided by 2 minus 0.927, and the other answer is giving me 2 theta is 10.1. And so this answer is giving me theta is equal to 5.05. But this answer is not valid. Not valid. Not valid. And this one is not valid. And the reason for that is because they told us, remember they told us that theta must be between 0 and 2. Theta must be between 0 and pi. Wait, actually this is fine. This is fine. It's between 0 and 2 pi. So those are what you're getting. Theta is either 1.89 or theta is 5.05. If you don't believe me, put it in the calculator. 3 sine 2 times 1.89. 2 times 1.89. 3 sine that. Plus 4 times the cosine of 2 times 1.89. I get my -5 for this. I'm putting 5.05 as well. You get 3 sine plus 4 cos. I get my -5. So both of these are fine. These two are the answer actually. These two are the answers. All right, any one of them is fine. All right, 1.89 and 5.05. I know it says find the value, but both of them satisfies it. Now it says determine the maximum and minimum value of 1 minus 7, 1 over 7 minus f of theta. So let's do the final part of this question. So to do the final part of this question, first we have to start with by saying f of theta is going to be bounded. It's bounded between 5 and -5. We know this. Good. So if I were to say minus f of theta, if I multiply through by -1, that's bounded by 5 and -5. All right. And then if I add 7 to both sides, I would get that 7 minus f of theta is bounded by, add 7 to 5, I get that it's bounded by 12. And I add 7 over here, it's bounded by 2. I then reciprocate it, I flip it and reciprocate it, and I get 1 over 7 minus f of theta. And that's bounded by, that's going to be bounded by 1 over 12. And this is 1 over 2. Nice and easy, soft. So then the question you may ask now is, what is the minimum value of f of theta? So you can just say, okay, the minimum value of that is going to be 1 over 12, and the maximum value is a half. That's how you do that question. Nice and easy, soft, no issues. That takes care of question number 3. Nice and easy. All right, we're on to question number 4. On to question number 4. Question number 4 says, let L1 and L2 be the diameters of a circle. The equations of L1 and L2 are x minus y plus 1 and x plus y minus 5 equals 0 respectively. Show that the coordinates of the center of the circle L1 and L2 intersect at 2, 3. So pretty much they're asking you to solve the equation simultaneously and show that the point of intersection is 2, 3. So you have a line x minus y plus 1, and that's equal to 0. And you have another line x plus y minus 5, that's equal to 0. If you're to add these two equations, let's just add them. If we add these two equations, we're going to get x plus x is 2x, y plus minus y cancel, 1 plus minus 5 is minus 4, is equal to 0, and so 2x minus 4 is 0, and so 2x is equal to 4, and so x must equal to x must equal to. Since x is equal to 2, we can resubstitute in a point up here. All right, so 2 minus y plus 1 is 0, and so y must be 3. Y has to be 3. All right, and so hence the center is 2, 3. Hence the center is 2, 3. So that gives us the center of the circle. Hence the center is 2, 3. Now that we get the center of the circle, we're looking pretty good. All right, we're looking pretty good now that the center of the circle is 2, 3. So that represents part A. All right, center of the circle is 2, 3. Now it says A and B are ends of the diameter. So anytime they're talking about diameters and endpoints, I just have to draw a circle. It just gives me a clear idea of what's going on. All right, so I'm just drawing this circle here, and it just really helps me when I do that. And I know the center of the circle is 2, 3. I know the center of the circle is 2, 3. I know that the line, you have the line y is equal to x plus 1. If I bring this over, I have the line y equal x plus 1. So that's a line like this, so y equal x plus 1. So this represents L1. That's L1. Then the line L2 would be, bring over this, it would be 5 minus x. 5 minus x is a line coming from down here. This would be the line L2. I'm just sketching it. It makes me see what they're talking about. And they said that A and B are endpoints of L1. So looking at L1, A and B are endpoints. So you have A and B. And they tell us that given that the coordinates of A is 1, 2. So A has coordinates 1, 2. And the diameter bisects each other, determine the coordinates of B. Now that's so easy, like this is B. Like to get from From here to here, remember the distance from here to here, let me put it like this. The distance from here to here is the same as the distance from here to here. All right, so the distance from A to the center is the same as the distance from C to D. So there's two ways you can do it. You could use the length of a line formula and say that the distance AC is equal to the distance CD. All right, so given that the two distances are equal, then that implies that B is going to be equal to the coordinates 3, 4. You might say, how do I know that right away? Look at it. You're going up by 1 for the x. You continue by 1. From here to here is 1. So you increase in x by 1. So you go from 1 to 2 to 3. That's from A to the center to B. That's for the x coordinate. For the y coordinate, the distance is going to be the same. And so it's going to go from 2 to 3 to 4. That's the easy way to do it. All right, so B is a 0.34. Nice. Next now it says, a point P moves in the xy plane such that its distance from C is 2, 3. Such that its distance from the center is 2, 3. And it says determine the locus of P. So it tells us that the distance from the center of the circle, so the distance from the center of the circle is root 2. So if the distance from the center of the circle is root 2, this is what you have. All right. I want to put a better sketch right here. And let me not use a circle yet. Let's say this is the center. This is C. C is the point 2, 3. And they're telling us that P is the point where P could be anywhere, P could be here, but all they're telling us is that P is the point such that the distance from the center to P is root 2. So they're telling us that this distance is root 2. So if this distance is root 2, P could be anywhere. As long as the distance is root 2, we could get one circle going around it. But as long as the distance as long as, let's say P is here, as long as the distance is root 2, we're good. And so this forms an equation of a circle. And so the locus of P, the locus is going to be given by x minus 2 all square, because it forms a circle, so it's x minus 2 all square plus y minus 3 all square. And that's equal to r squared, which is the length of the radius, which is 2. That's the answer. Nice and easy. So this was a very easy coordinate geometry question. Everything about it was easy. Everything. Nice and easy. So now let's look at the next part of it now. The next part should be parametric and vectors. So let's see. They tell us that the parametric equation is given by x is equal to 1 over 1 plus t, 1 over 1 plus t, that is x, and they tell us that y is equal to t over 1 minus t squared. Y is equal to t over 1 minus t squared. And then what they're asking us to do is they ask us to determine the Cartesian equation of S. So if we're to determine the Cartesian equation of S, if we're to determine the Cartesian equation of S that we need to make, we need to make it in terms of y in terms of x or x in terms of y. So looking at it, this one looks easy to make t the subject. So from this one, I'll do it in a different coloring. I can see that 1 plus t would be equal to 1 over x. And so I would be getting that t is equal to 1 over x minus 1. Some people might want to write it as 1 minus x over x. That's the value for t. All right, so I'm going to substitute t as 1 minus x over x into y. I'm going to sub it into y. And so what I'm going to get then is y is equal to t, which is 1 minus x over x. And all of this is divided by 1 minus t squared. T squared is going to be 1 minus x all squared over x squared. That's t squared. Given that the question is 6 marks, I don't think they want us to stop here. So let's simplify it. I'm just going to write back the numerator as it is, 1 minus x over x. And it's now being divided by, now this one can be looked as x squared over x squared. And then this is now minus, simplifying what is 1 minus x all squared. That part is going to work out to be 1 minus 2x plus x squared over x squared. That's what we're going to get. So now if we're to continue now, we're going to get that y is equal to, that's 1 minus x over x, and it's being divided by, simplify the numerator here, x squared minus x squared cancel, minus and minus become plus, so it becomes divided by 2x minus 1 over x squared. Now whenever you're dividing two fractions, you can rewrite it as 1 minus x over x, and that's being multiplied by, when you change the sign from division to multiplication, you flip it to get x squared over 2x minus 1. And so our x cancels out our x squared, x from the x squared. So the two going to cancel, and it cancels out this x. And so what we get then is y is actually equal to 1 minus x times x. Y is equal to 1 minus x times x over 2x minus 1. That is y. Nice and easy, soft. That's the answer. 1 minus x times x over 2x minus 1. That is y. Nice and easy. Now let's have a look at part C. Now that we're going to have a look at part C, for part C, let's look at part 1 first. For part C, we have that the points P, Q, and R are three vectors of a triangle PQR, and it says express each of the vectors PQ, QR, and RP in the form xi plus yj plus zk. All right, so let's do that. So we have vector PQ. First thing we need to know is that vector PQ is going to be equal to OQ minus OP. All right. Vector PQ is OQ minus OP. It's always vector of the last minus vector of the first. So it's going to be OQ minus OP. So OQ, remember, let's write out what is OQ. OQ is actually, well, it has in a lambda in it, so let's put it in vector form first, just to be a little bit, safe with lambda. So minus 1 lambda 5, that's OQ, minus OP, and we know that OP is 3 minus 2, and 3 minus 2 and 1. So vector PQ is going to work out to be minus 1 minus 3 is minus 4i, minus 4i. Lambda minus minus 2 becomes plus. Lambda plus 2 times j. Lambda plus 2 times j. And then we have 5 minus 1 is plus 4k. That's vector PQ. Nice and easy, soft. Now let's look at the next part now. It says find QR. Now vector QR is going to be equal to OR minus OQ. That's vector QR. Vector QR is OR minus OQ. So I need to work out that what is OR minus OQ. OR, as we know it, vector OR is 2i. Again, because it have the lambda, I want to play it safe. Anytime it have lambda, I play it safe. I'm just going to put it in vector form first and then convert it to ijk. So OR is 2, 1 minus 4, 2, 1 minus 4, minus vector OQ, and vector OQ is minus 1 lambda minus, so it's 2, 1 minus 4. This is now minus 1 lambda and 5. So 2 minus minus 1, that works out to be 2 minus minus 1 is 3, so that's 3i, plus 1 minus lambda j, 1 minus lambda j. Then you have minus 4 minus 5 is minus 9k. So that's vector QR. Now that we get vector QR, next thing we need is vector RP. Let's work out what's vector RP. Vector RP is equal to OP minus OR. Vector RP is OP minus OR. Alright, since vector RP is OP minus OR, now this one I can just go straight because OP, remember where was OP? This was OP, OP minus OR, this was OR, so OP minus OR, that's going to be 3 minus 2 is 1. That's just I. And you're going to have minus 2 minus minus 1. Minus 2 minus 1 is minus 3j. Write this letter. Minus 3j. Then you're going to have 1 minus minus 4 is plus 5k. Nice and easy, soft. Nice and easy. One minus minus 4, just making sure. Yes, that's 5k. So now we have these, and we're good. Now it says, hence find the value of lambda given that PQR is a right angled triangle with side PQ as the hypotenuse. So again, guys, I love to see a picture of what's going on. I cannot just do it like that. I have to get a picture. So I'm creating my X and Y axis. I know it is X, Y, Z, but ignore the Z coordinates. So OQ is -1 lambda. OP is 3 minus 2. So think of it this way. 3 minus 2 is here. So this is OP. Just ignore the Z component for now. This will be OP, right? And then you have OR 2, 1, 2, 1, 2, 1, somewhere here. This is R. All right, so remember P is we're only looking at the X and Y coordinates. So it's 3 minus 2. R is the point 2, 1. And then we don't know where Q is, but based on what they said that PQ is the hypotenuse. So PQ is the longest side. PQ is the longest side. So where can we put Q? PQ is the hypotenuse. So maybe Q is somewhere here. I'm just putting a point, all right? Just putting a point. Well, actually, Q is -1 lambda. Q will be somewhere over here. All right, so let me not draw that yet. Q is somewhere over here. Let's say Q is right here. All right, let's say this is Q. So those are the 3 points, and I'm saying, imagine this now, say have right angle triangle PQ. PQ is the hypotenuse, and so then that means that the right angle would have to be somewhere at PR. All right, the right angle is somewhere right here. All right, the right angle is somewhere right here. All right, and this is the hypotenuse. And so now we need to determine the value of lambda. To determine the value of lambda, since this is a right angle triangle, then we know that the dot product is 0, or you can know that the angle at R is 0. So generally, what that means is, since we have QR, you know that QR dot PR must be equal to 0, right? So since the angle at R is 90, this is part 2. Looking at the diagram, right, we know that since triangle RPQ is a right angle triangle, since it's a right angle triangle, then what that is telling us then is that QR dot, the dot product between QR, so QR dot PR must be equal to 0. So we're going to use that dot product to solve for lambda. So doing that now, QR is 3, 1 minus lambda, minus 9, that's QR, dot RP, RP would just be in the opposite direction to this, so this would just be -1 positive 3 minus 5, that's equal to 0. So what does that mean? That implies that 3 times minus 1 is minus 3, plus 3 times 1 minus lambda is 3, minus 3 lambda, and then minus 9 times minus 5, that's plus 45, that's equal to 0. So what does that tell us? That tells us then that 3 lambda minus 3 plus 3 cancel each other, and so 3 lambda is equal to 45. 3 lambda is 45, and so lambda is 15. So lambda equals to 15. That's the answer. Lambda is 15. I don't see why you get 6 marks for this. They were very generous, but that's it. Nice and easy, soft. Lambda is 15. And now we go to module 3. Module 3, we're going to start with question